Hey guys, my name is Trevor Sullivan, and welcome back to my video channel. Thanks so much for joining me for another video, and what we're going to be talking about today is a slight deviation from my recent videos. I've got a couple of other playlists on my channel that you'll probably want to check out. One covers the LXD container and virtualization platform, and the other playlist is around Windmill, which is an open source, self-hosted, low-code application development platform. But in today's topic, we're actually going to be talking about a database platform that I came across, and I'm really excited about it because it's very high performance and it's very simple to get started with as well, but it's still very powerful as well. So you want to check this database platform out called ArangoDB. The reason that I like this database platform, aside from its high performance and its simplicity, is the fact that it's open source and self-hosted as well. So you can either use their managed cloud platform to provision an instance of ArangoDB, or you can actually just go out to the GitHub repository for it and find the source code. Plus, you can also deploy it very easily by using a Docker container model, or you could deploy it as a container running on Kubernetes as well. So, what is ArangoDB and why would you want to consider using it? Well, let's check out their website to get a little bit more insight to what ArangoDB is all about. So, if we take a look at their homepage here, you can see that it is a graph database platform. So, graph databases are quite a bit different than a traditional table-based or relational database model like MySQL or PostgreSQL, because a graph database is built around the concept of having a graph of resources where you have different vertices on your graph that represent things. A thing could be a person, it could be a car, it could be an airplane, it could be a drone in a drone fleet. And then we also have the edges or connections and relationships between the different things or vertices that we have in our graph database. This is a really powerful way to visualize all sorts of different types of data. Another example could be something like a real estate application where you're representing different properties that are for sale or for rent. So you can kind of express interest in different properties, perhaps, and have a relationship between yourself as a person, as a vertex, and a piece of property that you're interested in purchasing. Again, there's just tons of different ways to represent this data. But what I really like about it is that you can represent any type of data in here. So it's really useful for developers. It's good for, software architects or network architects who maybe need to manage networks and need to represent different routers or switches as entities within their network, or maybe even access points, and then show relationships between all those different entities. It can also be used by data scientists for artificial intelligence data modeling as well. So there's just tons of different use cases for ArangoDB. So as I mentioned, it is open source and it runs pretty much anywhere thanks to containerization. It's also pre-packaged using things like Debian packages if you want to install it natively on a Linux operating system as well. So it's actually really good to go explore my training on LXD because that allows you to provision the virtual infrastructure, and then you can simply install ArangoDB on top of your Linux virtual machines. Now, how do you actually query data in the ArangoDB? Well, you can actually use this language called AQL. It's short for ArangoDB Query Language, and they've basically come up with their own query language in order to insert data into an ArangoDB database, as well as querying data out of the database. And it's actually really easy to build and test queries because ArangoDB actually includes a web-based management interface. So all we have to do is spin up ArangoDB, and we can immediately start working with what are known as collections. That's how we actually store our data in ArangoDB. And then it actually has a miniature query editor as well, so that we can build and test our queries before we embed those queries into our application code. Now, ArangoDB has been around for quite a long time. They actually have their own Wikipedia page here. And if you take a look at when they initially released ArangoDB, it was actually in 2011. So this database is around 12 years old at this point, and it has been around for quite a while, and it's written in C++ as well. It uses a backend known as RocksDB, and RocksDB is basically a C library that allows you to store data in a key value storage language format. So because it's written in C, it is very high performance. And of course, because ArangoDB is built on top of that RocksDB engine, it's also very high performance as well. They're currently on a 3.x branch here, and you can see the 3.x branch goes all the way back to 2016. So this branch has been in development for about 7 years at this point, incrementally. One of the newest features that they actually added here is support for ARM-based CPUs as well. So if you're deploying into the cloud like AWS and you want to use the AWS Graviton CPU, which is a little bit less expensive than Intel and AMD-based CPUs, but it provides very good performance, then you can actually use the ARM-based support for ArangoDB as well. Also, devices like Raspberry Pis or the Odroid devices use ARM-based CPUs. I actually use a device called an Odroid M1 that has a multi-core ARM-based CPU, so I could run ArangoDB on any of those types of devices. So check out their Wikipedia product page because that does talk a little bit about their platform and some of the history about the company. It is based in Germany here as well, so it is a German-based product here. And again, it's open source, so you can pretty much just see the source code and customize it, contribute to documentation if you want to, and just be able to kind of see how the product is developing. Now, they also have a free training course here over on Udemy. So if you're looking for kind of a technical deep dive into the internals of the Arango database engine, they have a about 2.5 hour training course here that's very well reviewed. It was created by one of the developer relations engineers over at ArangoDB named Christopher Woodward. So make sure that you check out this course if you want to go into the internals of how Arango actually works and how to write queries and how it works architecturally. Now, just to give you a quick example of what we are going to be working with here, this is actually the web interface of ArangoDB running on my own server. This is actually running inside of a Docker container, and we'll take a look at how to deploy it in just a moment. But I wanted to show you really quickly what the web interface looks like here. You can see that I've created a couple of document collections here. And if I take a look at this content tab, you can see that I've actually added a couple of documents in here. So fundamentally, ArangoDB works as a document storage engine, but then you can also add the edges or relationships between different nodes in the ArangoDB graph database, and that's what kind of turns it from just a document storage engine into a full graph database that you can write queries against as well. So let's go ahead and actually talk about how to deploy ArangoDB. Now, you don't have to use containers if you don't want to, but I generally prefer using a container deployment model just because it's very easy to spin up new instances of containers on a virtual machine somewhere, and it's also very easy to destroy them and just kind of restart from scratch. So containers provide a really easy way to initially deploy as well as upgrade applications to newer versions as well. Now, you can use what are known as container image tags over here on the Docker Hub. So if you go to hub.docker.com, just do a search for ArangoDB. You can see that there's all these different image version tags. So if you want to run, the absolute cutting edge version here, you could use the 3.11 tag. You could also use a historical version if you need to run automated tests against older versions of the database engine to make sure that your application still works with those older versions. So it's really nice to be able to just kind of select which version of the database engine that you want to use. But I'm just going to stick with the latest tag. And if you take a look at the little hash right here, that hash actually corresponds to the 3.11 version. So I could either specify 3.11, I could do 3.11.2 if I wanted to be even more specific, or I could just use the latest tag here. So what you'll need in order to kind of follow along here is a Linux virtual machine. We'll also have Docker installed as well. I'm not going to show you how to install Docker because I'm just kind of hoping that you already have Docker installed on your system. So let's go ahead and fire up an SSH session to our Linux virtual machine. So I'm going to jump into my server called Wyoming right here, and this is going to be the server that I actually run a container on. So if I do a docker run command right here, I can specify the ArangoDB repository right here, and then I can specify the tag that I want. So let's say ArangoDB, and we'll just use that latest tag. But there's some additional parameters that we're going to need to specify when we spin up an ArangoDB database. So what we're going to want to do is check out the documentation for ArangoDB right here. So let's go back to the Overview tab. And there's an environment variable that we can set called Arango random root password. And if we just set that to a value like 1, then that will dynamically generate a secure password for us to log in as the root user, which is the default user out of the box with ArangoDB. Also, we would want to specify the -d parameter here, or --detach, and that's how we ensure that our shell detaches from the container and that the container service just continues to run in the background on our Linux server. So back here in our shell, we'll do --env arango underscore random underscore root underscore password. We'll say equal to 1, and then we'll do --detach as well. And a couple of things that they don't mention is that you'll generally want to do pull equals always. So if there's a new version of the container image that comes out under the latest tag, then it'll download the latest version before it starts the container. And also, I generally like to do restart equals unless stopped, and that'll ensure that if I restart my Linux server, that this container will automatically be brought back online rather than me having to go manually start this container every time that I restart my server. All right, so let's go ahead and run this command. And as you can see, we spun up a new container. Now, due to the way that Docker networking works, we don't have access to this container, so I'm actually going to delete it by doing docker rm 525. Let's do --force here as well. And what I'm going to do now is actually publish a port for this container. And the port that ArangoDB uses, let's just do --publish, is 8529, I believe. Let's take a look for the port number right here. So yeah, it's 8529 that it'll be listening on. So let's just map a unique port because I'm already using that port. So I'll use, how about 8560? And I'll just publish that into 8529 inside of the container. So now I can hit my Linux host on port 8560 and access this service. So what we'll do is head over to our browser, and I'll just fire up the IP address of my server right here and then specify port 8560. And that'll take us to the ArangoDB web interface here. So now we can log in as the root user, but we need to figure out what the randomly generated password was. So to do that, we're going to take a look at the container ID right here, or at least the first few characters of it. And we're just going to do docker logs on that container ID. And if you scroll up to the top right here, you'll see that we have in the very first message here that we have a generated root password. So we can just copy that dynamically generated password, paste it in, and log in as the root user into our brand new ArangoDB instance. By default, there's only going to be a single database called the _system database. This is kind of an internal database that's used by ArangoDB. So we'll just go ahead and select that DB for now. And the system database is a little bit special. And the reason for that is because if we need to do any kind of user management and assign permissions to other databases within our ArangoDB server, the system database is where we would do that. So rather than going directly into collections and adding new collections and adding data into this system database, let's actually create a new database and switch into that database rather than just using the system one. So I'm going to add a new database here called Trevor Sullivan, and we'll hit create right here. And the other thing that I want to do is to create a new user as well and assign that user permissions to the new database that I just created. So I'll create a user here called Trevor, and I'll give it a password like bacon123 exclamation point. And then we'll go ahead and just set that as active. We'll do create on that user. And then we need to go into the user configuration here and go to the permissions tab. And this is where we can specify that the user has administrative permissions over the Trevor Sullivan database that we just created. And we also want to make sure that it has access to all of the collections inside of that database. So we'll give the Trevor user read-write access to star or all collections inside of the Trevor Sullivan database. If you only give it access permissions, then the user will not be able to create or delete collections. So since we have a brand new empty ArangoDB database, we want to make sure that the user is able to create and manage collections in addition to managing the documents or data inside of those collections as well. All right, so now that we've made those changes, there is no save button. These just take effect in real time here. So what we're going to do is actually log out of our instance right here. So let's go ahead and just do log out. So we're going to change user, log out, and then we're going to log in as our Trevor user, plug in our password right here. And now in the drop-down box here, you can see that the Trevor user only has access to the Trevor Sullivan database. It doesn't have access to the system database. So the Trevor Sullivan database is the only one that we can select. So now we are working in a brand new database as a somewhat limited user, but this user has, again, administrative access over this Trevor Sullivan database, so we can do whatever kind of management tasks we need to inside of this database. So the first thing that you're typically going to do in ArangoDB is to create what's known as a document collection. And a document collection is basically just a place for you to store JSON-based data. And this data can have any schema or structure that you want it to have, because by default, a collection is schemaless. Now, you can assign a specific schema if you want to enforce data integrity inside of a collection, but that is not a mandatory feature of ArangoDB. So let's go ahead and just create a collection here called cars, for example. And there's two different types of collections. There's our core document type of collection that allows us to store arbitrary data. And then there's this special type of collection called the edge collection that's used to establish relationships between entities in document collections. So I'll just hit save right here. That'll create my brand new cars collection right here. And you'll notice at first just how snappy this interface is. The web interface for Arango is incredibly high performance. It's very, very snappy. So that's one of the things I really like about it. And it's also just very simple to understand, very simple to use here as well. So now that we're in the cars collection, let's go to the content tab, and you'll see that we don't have any documents currently. So if we just click on the little plus sign here, we can create a new arbitrary type of document. So let's go ahead and just add in some data, like manufacturer is maybe Chevrolet, and we'll go ahead and give it a type, like maybe a truck. And then we'll also give it a VIN. And the VIN, if you're familiar with that, is a vehicle identification number that uniquely identifies every single vehicle that's manufactured. So I'm not going to use an actual VIN number. I'm just going to use a random number here, like 789, as a string value. But of course, you could use a real VIN structure if you wanted to. So we'll go ahead and just create that here. And now we can just click on this little plus document sign and create some additional records. So now I'll do manufacturer, say Toyota, and then say type is maybe car, and then VIN is going to be 678 instead, and we'll make that a string as well. And we can also add arbitrary properties. We don't have to follow the schema of the first entity or document that we created inside of this collection. So I'll just do color is red, and now we should be able to create this. Let me put a comma right there after type. And so now we've got two different objects inside of our collection here. So let's come back to our cars collection, and we now have two different documents inside of our collection. You're going to want to take special note of the key. The key uniquely identifies a specific document inside of an ArangoDB collection, and then the ID up here includes the collection as a prefix to it as well. So that's a way for ArangoDB more generally to identify a specific collection inside of a database and then the specific document that we are referencing here. So when you create relationships between different types of objects or documents inside of different collections, this collection ID here is the kind of internal system property that's used to uniquely identify each document inside of each collection within a given ArangoDB database. So let's go ahead and create another collection here, and we're going to call this maybe owners, right? So each car has an owner. And so I'm going to create another type of document collection here, and we're just going to add a couple of people into this owners collection. So I'll go ahead and give it a first name property here of Trevor, and then we'll go ahead and add another document here called first name, how about Benjamin, and do create, and I'll create a third one called first name Shelly. All right, so now we've got several different owners inside of the owners table here, first name Trevor, first name Benjamin, and first name Shelly. Now, at the moment, we have two different collections. Cars has two documents, and our owners collection has three documents. Now, there's no relationship between any of these documents at the moment, other than the fact that the owners belong to a given collection and the cars belong to a given collection. So if we wanted to create an owner to vehicle relationship between these documents inside of ArangoDB, we would actually need to create another type of collection here of type edge. So the edge collection is a special type in ArangoDB that allows us to define the relationship between, let's say, an owner and a car or any other type of entity that you define inside of your ArangoDB database. So I'm just going to call this owned car and click on save right here. And now you can see that the icon used for an edge type collection is a little bit different. Now, when we try to add an item into one of these edge collections, you're going to see that we have a special property here called underscore from and underscore to. And this allows us to identify the collection document that we want to start with and point to. And this is how we create that relationship between two different entities. So the from is going to be an owner because an owner owns a car, right? So what we can do is specify a particular document ID inside of the owner's collection in the from field, and then we can specify a different ID of a car in the to field right here. So let's actually go ahead and come back to these collections and grab a couple of IDs. So I'm going to go ahead and grab this car ID right here for the Toyota car, and then back in the owner's collection, I'm going to grab the ID for Shelly here, which is owners/469. So let's go back to our owned car collection here, go back to content, and we'll add a new document. The from is going to be the owner, so owners/469, and then to is going to be the car that is owned by that particular owner. And so in this case, it's going to be the red Toyota car, which is cars/395. And then down in the document body, we can add any data properties into our JSON document here that represent the ownership state of this vehicle. So for example, we might have a start date. So what is the first date that Shelly owned this particular vehicle? And so we could set that to something like 2023-10-18. And then we could also have something like an end date. So if Shelly ever sells this vehicle, we can specify that there still was a historical relationship between Shelly and this vehicle, but by specifying this end date property, we could just say that that is going to define when she sold the car. So we'll say she sold it a day later in 2023-10-19. And then somebody else might have a new relationship to this car that starts on 2023-10-19 and continues to a future date. All right, so now we've created that relationship here, and there's now an edge or a relationship between Shelly, the owner, and the car, which is the Toyota, right? So now what we can do is go over to graphs right here, and we can add what's known as a named graph in ArangoDB. And so I'm just going to call this owned vehicles. And this allows us to define a couple of different entities as input here. So first is going to be the relationships that we want to visualize. So of course, we only have one collection of type edge. So we're going to choose owned car. Then we can specify the from collections. So what are the collections that contain documents that we want to start as the source? So we're going to do owners right here. And then to collections, what are the collections that we want to visualize that are owned by a particular owner? So we could say, well, I want to specify cars are owned by owners as the from collection here. So now I'll just click on the create button right here to create this graph. And if we click on this graph, you can see that by default, it loaded this relationship between owner 469, which is Shelly. If we hover over first name as the attribute, you can see it says Shelly. And then if we click on the car right here, that is the Toyota car with a color of red. And there's this owned relationship between Shelly and that vehicle. Now you'll notice that our other owners and other vehicles are not currently showing up on this graph. So we could just click on this button right here that says load full graph, and it'll give you a warning because this could have a lot of data depending on the size of your database. But because we're working with a relatively small database here, I don't need to worry about that. We only have a few vertices or a few documents here, and we only have one relationship. So we aren't really dealing with very much data here at all. So now we have our other entities here, like owner 453, and that is the Trevor owner, and 375 here, that represents the car with the manufacturer of Chevrolet, type truck, and a VIN of 789. All right, so now what we can do is go over to settings here, and there are some different things that you can do to change the configuration of your visualization right here. So one thing I like to do is say color nodes by collection, because right now the owners and the vehicles themselves or the cars are currently displayed all in the same color. So if we choose to color the nodes by the collection, that will segment them by category. And then I can also show the collection name here. So that clearly shows me which collection each entity belongs to. So let's go ahead and apply that change, and then we'll reload the entire graph right here. So now our cars are represented in yellow vertices, and our owners are now represented in these blue vertices instead. So this just makes things quite a bit easier to visualize rather than just having the document ID available underneath the vertex. So you can start to see how powerful this is by us building different collections that contain these entities or vertices, and then the edge collection that defines JSON documents that actually declare the relationships between these different entities. Now, let's say that we wanted to enforce the integrity of a certain data structure. At the moment, we have these cars that currently have different schemas. So one car has manufacturer, type, and VIN properties, whereas the other car has manufacturer, type, VIN, and color as well. So what we can do is go into the schema tab right here, and as you'll notice, each collection by default has a null schema, but we can actually insert a custom schema in order to specify what the data structure of each of these collections should look like. So what we'll do is head over to the documentation. So if we go to the main arangodb.com site and go to learn and then documentation, and let's just do a search for schema. Go to schema validation right here. They actually have an example of what a schema can look like here and how we can declare these rules on the different properties that we expect to be available on this particular collection. So let's go ahead and specify the root object here, and we'll specify a new rule right here. And then inside of that rule, we want to go ahead and specify properties here. And then we can specify any properties that should exist on the cars. So we'll say properties, and then we'll call it manufacturer. And this will have a type of string. And then we can also add some additional properties as well. So let's just copy manufacturer and then specify the type and VIN and color as well. So let's specify type and then VIN and then color down here as well. And for simplicity, those will just be all of type string. All right, so now what we're going to do is specify this required field right here, and this allows us to specify an array of fields that or attributes that are mandatory on each of the documents inside of this collection. So what we'll do is go down to our rule and say required, create an array, and then we're just going to specify that all of these attributes, manufacturer, type, VIN, and color, are all going to be required by each document in this collection. So we'll say manufacturer, type, VIN, and then color. All right, so now we'll go ahead and try to save that schema. And it looks like we have a little bit of a bug here. So let's see what is missing. And it looks like I actually have an extra comma right here at the end because I just duplicated that. So let's get rid of that extra comma. Click on save. Now we have a little bit of a different issue, which is that I'm missing a comma on line 16 to go to the next property, which is required. So let's go ahead and try that. And now it's complaining about the invalid primitive type capital string. So I actually need to use lowercase s for each of these strings. And if you check out the schema validation here, you can see that they are using lowercase s on the type there. Let's go ahead and try to save that. So now we've updated the schema for the cars collection. So if we go back to content right here, you'll notice that we currently have one document, which is the Chevrolet truck right here, that does not currently match the schema, right? So let's go ahead and actually see if we can bring this into compliance with the schema, or actually let's go ahead and add a new document here and see what happens if we try to specify an invalid item. So we'll do manufacturer and we'll set that to, how about Ford? We'll do type of car, and then we'll do a color of, let's say, silver. And let's go ahead and try to create that and check it out. It says schema validation has failed. Now the error down here doesn't tell us specifically why it failed, but if you know the schema for this collection that we just created, you'll know that we are missing the VIN property down here. So we'll go ahead and add that and set it to 234. And then we'll click on create. And now this collection allows us to create a document as long as it matches the desired JSON schema for this cars collection. So now we have a bunch of cars, a bunch of owners. We have relationships between the owners and the cars. But one other thing that I wanted to show you is how you can actually build a relationship without having to go into the Edge collection and create a new document and paste in the from and to fields. So what we can actually do is go back to our named graph right here called owned vehicles, and let's just reload the entire graph right here. So now we have 3 cars and we have 3 owners, and we only have one relationship. So let's say that the owner right down here, 453, which is the Trevor owner, we want to make Trevor own a car that we just created, which is the Ford silver car with a VIN of 234. So how do we draw a relationship between 453 owner and 971 car? Well, what we can actually do in the graph view is just right click in this context menu and say add edge to database. And so now we can literally just start with the owner and just click and drag over to the car. And those IDs for the 2 documents that we want to link together with this edge collection are now automatically inserted. So now what I can do is just customize my document and say start date is how about 2024-03-04 and click on create. And now we have a relationship between that owner and that car. And we didn't have to manually grab the IDs for either of those entities because we can do it right here in this graphical interface. So anyways, those are just some basics of the ArangoDB platform right here. I guess there is one other thing that I wanted to show you as well, which is how you can actually query data from collections. So let's go over to queries right here. And now we can go ahead and take a look at the documentation for AQL, which is right up here. And if we take a look at the data queries right here, this will show us how to actually structure a query. But let's just take a quick look at how we would query for cars inside of our collection. So we're going to use for here to iterate over entities within a collection. So we'll just say for car in, and then we specify the collection that we want to retrieve documents from. So we'll say cars, and then we'll say return the car. So for each car document inside of the cars collection, we just want to return that car. And let me make sure I have the collection name correct here as well. So let's just copy that query. And yeah, it's called cars. So now what we'll do is just click on execute right down here. And let's do a capital C cars right here. That's what I thought I probably got wrong there. And now you can see right down here, we have a query that returned 3 elements. So we can see the documents that were returned by this particular query right down here. We could also do the same thing for people or owners. So for owner in the owners collection, return the owner. We can also specify specific properties like first name. Let's just grab the first name property, and you can see that we get an array of only the first name property from each of those documents. So Trevor, Benjamin, and Shelley. So that's pretty much everything I wanted to show you with ArangoDB. We took a look at a bunch of different concepts inside of this video. We spun up a brand new ArangoDB server using Docker. We also created a custom database and a custom user, gave that user permission to the database. We also took a look at how to create collections, collection schemas, adding documents to collections, and then how to use the special type of collection called the edge collection in order to create a relationship between entities in different collections in ArangoDB. So feel free to spin up ArangoDB for yourself. Love the simplicity, love the performance of ArangoDB, and just how easy it is to get started and integrate it into your applications. In fact, one of the great things about ArangoDB is that it actually has an HTTP API here. So even if there isn't a supported driver for the programming language that you're using, like maybe you're using PowerShell as a developer, if there is no official driver for PowerShell, you can actually just go straight to the HTTP API for ArangoDB and interact with the database that way, since of course from pretty much any language, you can use an HTTP client and send and receive JSON data. Anyway, I hope you guys enjoyed this video and learned something new. Again, I encourage you to go out and deploy your own ArangoDB server, start playing around with it, create some data, create some relationships, create some queries, and then try to incorporate those queries into your application. Thanks again for watching. Make sure to like this video if you learned anything new. Leave a comment down below to let me know what you thought of this video and the other videos on my channel, and make sure that you subscribe to my channel to help me grow this community. We'll see you in the next video. Take care.